In this video, we're going to take a look at the sum and difference formulas for two angles within trigonometry. And I've noticed that there are two different ways that these particular problems are presented. And so we're going to take a look at the two different ways that you might see them in your homework assignment. So the first example says, given that the sine of angle A equals -5/13 and that A is in quadrant 3, and the sine of angle B is equal to -7/25, and B is in quadrant 4, they want you to find sine of A plus B. So there's really a lot of things going on here, but the first thing that kind of jumps out at me is that I realize they ultimately want me to find the sum of the two angles. And so I'm ultimately trying to find the sine of angle A plus angle B. So I'm going to go out and I'm going to write down my formula for the sum of angle A plus angle B. Now, these formulas are on the formula sheet that you will be using for the final exam. Okay, so you can go out and look at those. And then I'm going to transfer the one for the sum over to my paper. So the formula for the sine of A plus B is the sine of angle A times the cosine of angle B plus the cosine of angle A times the sine of angle B. And so if I think about what information I was given or what information I have, I'm told in the problem initially, I know the value of the sine of A, and I also know the value of sine of B, but I don't know the cosine for either angle. So that's really the first thing that I have to do in order to complete the formula or the calculation for the sum of angle A plus angle B. I have to first determine the cosine. Now, there are a couple of ways, again, that you can do that. The easiest way is to use your Pythagorean identity. So I'm going to use the Pythagorean identity. I'm actually going to do it twice, once for angle A and once for angle B. Okay, remember my Pythagorean identity is the cosine squared of angle A plus the sine squared of angle A is equal to 1. And I know the sine squared, or I know the sine value, so I'm going to plug that in. So I have cosine squared A plus -5/13 squared, and that equals 1 whole. So if I continue with those calculations, let me scroll down. Okay, so I have some room to write. So I have cosine squared A plus, and I'm going to square this. -5 times -5 is 25. 13 times 13 is 169, and that equals 1 whole. So I'm going to subtract 25 over 169 from either side to isolate the cosine. And let me get rid of that stuff that we don't need. Okay, so when I do that, I have cosine squared A equals 1 whole minus 25. Well, 1 whole would be 169 over 169. So minus 25, 169 minus 25 would be 144 over 169. But that's cosine squared, and I'm not looking for the square. I'm looking for plain old cosine. So to find plain old cosine, we take the square root of both sides. So I'm going to square root both sides of the equation. So I would take the square root of cosine of 8 squared of A, and then I know it can be plus or minus. So I have the cosine of angle A equals the square root of 144 is 12. The square root of 169 is 13. And then I need to decide, is it positive or negative? Well, I'm told that angle A is in quadrant 3. In quadrant 3, the cosine or the x-coordinate would be negative. So cosine A is negative 12/13. Okay, then I'm going to go back and I'm basically going to use that same Pythagorean identity again, but I'm going to do it for angle B. So I would have cosine squared B. I'm going to have cosine squared for angle B plus sine squared angle B equals 1. Okay. Again, I know what sine B is, so I have cosine squared B plus negative 7/25 squared equals 1. So I'm going to work that out. So I have cosine squared B plus 7 squared is 49 over 25 squared, which is 625, equals 1 whole. And again, I'm trying to ultimately solve for the cosine of B. So I would have, I'm going to subtract 49 6/25 from either side. Okay, so I have cosine squared B equals 625 minus 49 is 576. Remember, 1 whole would be 625 over 625 minus 49 is 576 over 625. Again, I need to take the square root of both sides to get rid of the square, realizing it could be positive or negative. So I have cosine of B equals the square root of 576, is 24. The square root of 625 is 25. And I'm told initially that B is in quadrant 4. In quadrant 4, the cosine is positive. So here is my cosine B. So I was given sine of A. I just figured cosine of B. I calculated cosine A, and I have sine B. So now it becomes a matter of substitution. So let me scroll down here. I'm going to rewrite the formula, okay, so you can see exactly what I'm doing. I have sine of A plus B is the sine of A times the cosine of B plus the cosine of A times the sine of B. And I'm going to basically do substitution, okay? So I was given the fact that sine A is negative 5/13, okay? And, okay, so we're going to do that substitution. For sine A, we were given negative 5/13. Cosine B, we calculated to be 24 over 25, plus cosine A, we calculated to be negative 12/13. And sine B, if I scroll back up and look, was given as negative 7/25. Okay, and then I'm going to do the math. Okay, so remember, when you multiply fractions, you multiply the numerators, you multiply the denominators. So 5 times 24, or negative 5 times 24, would be negative 120 over 13 times 25 is 325, plus 12 times 7, negative 12 times negative 7 is positive 84 over 13 times 25, which we already determined to be 325. So then I have negative 120 over 325 plus 84. So negative 120 plus 84 is negative 36. So I'm going to have negative 36 over 325. There's your answer. This is the sign of A plus B. And again, the benefit of doing that is that you get an exact value as opposed to an estimated value, which is typically the whole point of using sum and difference formulas or power reducing formulas or half angle or double angle, is it gives you an exact value as opposed to an estimate. Okay, so let's look at another one that was kind of in that format. Given that cosine A equals 3/5 and A is in quadrant 1, and that sine B is negative 24 over 25, and B is in quadrant 3, find cosine of A minus B. Okay, so again, initially, I'm going to write down my formula and see what pieces I know and what pieces I need. So I have the cosine of A minus B. Okay, and remember the formula is going to be on your formula sheet. So you got the cosine of A minus B equals cosine A times cosine B plus sine A sine B. Okay. Then, if I think about what pieces I already know, I was given cosine A and I was given sine B. So I need to find the sine of A and the cosine of B. And again, I could use my Pythagorean identity to do that. Okay, so I'm going to use my Pythagorean identity twice. Which would be cosine squared A plus sine squared B equals 1. And I'm going to do it twice so that I can find the two pieces that I'm missing within my formula. So if I start out trying to find the sine of A, okay, so I know that, sorry, I got this formula written wrong. It should be A. Okay, so I have cosine squared A plus sine squared A equals 1. Well, cosine of A is 3/5. So I'm going to have 3/5 squared plus sine squared A equals 1. Okay, do the squaring. 3 times 3 is 9. 5 times 5 is 25. Plus sine squared A equals 1 whole. Again, remember, I'm trying to solve, in this case, for sine. So I'm going to subtract the 9/25 from either side. So I have minus 9/25 minus 9/25. Remember, 1 whole would be 25 over 25. So I have the sine squared of A is 16 over 25. I don't need sine squared. I just need plain old sine. So I'm going to undo the square by taking the square root, remembering it could be positive or negative. So the sine of angle A equals square root of 16 is 4, square root of 25 is 5. thinking about whether it's positive or negative. Angle A, we're told, is in quadrant 1. In quadrant 1, both your cosine and your sine are positive. So sine of A is 4/5. Okay, so now in terms of the formula, I know sine A. So I'm going to go back. I'm going to start over. And I'm going to look for cosine B. So I've got cosine squared B plus sine squared B equals 1. And I'm going to perform the substitution. I know that sine B is negative 24/25. So cosine squared B plus negative 24/25 squared equals 1. So cosine squared B plus 24 times 24 is 576. 25 times 25 is 625. That equals 1 whole. I then need to subtract 576 over 625 from either side. So I have cosine squared B equals 625 minus 576 is 49. So I would have 49 over 625. Again, I'm looking for plain old cosine, not cosine squared. So we're going to square root both sides, remembering it could be positive or negative. So cosine of B would equal 7/25. And we're told initially that B is in quadrant 3. In quadrant 3, both your cosine and your sine are negative. Okay, so my answer is the cosine of B equals negative 7/25. So what I've accomplished is I now have all of the pieces that I need to substitute into my cosine problem. Okay, so I'm ready to do the substitution. And again, I'll copy the formula down for you, okay, so that we can look at it. So I'm going to scroll back down. Oops, a little bit too far. Okay, so writing the formula down, we're doing cosine. We're doing A plus B. Let's see, make sure I get the problem right. A minus B. Cosine of A minus B, we would have the cosine of A times the cosine of B plus sine A sine B. Okay, so we're going to do the substitution. We got all the numbers. Cosine A was 3/5. Okay, cosine A was 3/5. I'm going to do the substitution now. Cosine B, we calculated to be negative 7/25. Plus the sine of A we determined to be 4/5 times sine B, and that was given to us. Sine B was negative 24/25. Okay, and then I just do the basic math. Multiply the fractions together. Remember, you multiply the numerators together, multiply the denominators together. So I have 3 times negative 7 is negative 21. Okay, so we have negative 21 over 5 times 125, or excuse me, 5 times 25 is 125, plus 4 times negative 24 is negative 96 over 125. So we have negative 21 over 125 plus negative 96 over 125. So when you add those two numbers together, we're going to get negative 117 over 125. And there's your answer for cosine A minus cosine B. It's almost like you have 3 questions in one, because you have to find the 2 missing pieces that you need for the formula, and then you have to work the formula out. Another way that the problems are presented, it might be that they give you something like find, I'm scrolling down, find cosine of 105 degrees. And again, the point of a problem like this is so that you want to try to be able to use the unit circle. Well, if you look at the unit circle, which is on your formula sheet for the midterm, or excuse me, for the final exam, you don't have 105. But are there 2 angles that you can add together, or 2 angles that you can subtract that would give you 105? Well, it jumps out at me, the first one that jumps out at me, I could take a cosine of a 60-degree angle plus a 45-degree angle, and I can combine those together, and that's going to be the value. And again, what that gives me is it gives me the exact value that I would have. Okay, so if I treat this, I can do this formula, okay? And I'm going to let A be my 60-degree angle, and B be my 45. And so if I use the formula for adding 2 angles together for cosine, the formula is cosine of A times cosine B minus the sine of A sine of B. And you where do those numbers come from? Because those numbers are off of the unit circle by looking at those 2 angles. So if I rewrite this with my angles in there, I'm going to do cosine of 60 degrees times the cosine of 45 degrees minus the sine of 60 degrees times the sine of 45 degrees. Okay? And so I can go back and forth to my circle. Okay? So if I go out to my circle, and I look at 60 degrees. My cosine is positive 1/2. Okay, so I plug that in. Cosine of 60 degrees is positive 1/2. And I'm having difficulty with this machine today, guys. It doesn't want to cooperate. Okay, so I have 1/2 cosine of 60. Cosine of 45 is square root 2 over 2 minus the sine of 60 is square root 3 over 2, and the sine of 45 is again square root 2 over 2. And again, you get all those numbers from the unit circle. I just need to toggle back and forth. Okay, then I'm going to perform the multiplication. Remember, multiply the numerators, multiply the denominators. So I would have 1 times the square root of 2, which is the square root of 2 over 4, minus square root 3 times square root 2, we would get square root 6, and multiply underneath. 3 times 2 is 6, over square root 4. Since I have a common denominator, I can add my terms together. Not literally, though, we would have the square root of 2 minus the square root of 6. all over 4. And that's the exact value for the cosine of 105 degrees. Again, the benefit of that is it gives you the exact value. And probably in some ways the most challenging part is figuring out which two angles you could use for 105 degrees. Okay. Again, I used the one that kind of jumped out at me first and went from there. Okay, one more. We have the sine of 5 pi 12ths. Again, if I go out and I look at my unit circle doesn't have 5 pi 12ths. And this one's a little bit harder to do because we're not as familiar with pi units, but I may have to think about it. It may help to convert it to the actual degrees and then work it from there. But I figured out that the sine of 5 pi 12ths could be rewritten as the sine of 3 pi 4ths minus pi 3rds. Okay, and I have the angle of 3 pi 4ths and pi 3rds on my unit circle, okay, because I'm trying to use values off the unit circle so I can have exact values. So the formula for the sine when you're subtracting, 3/4 would be my A, 3 pi 4ths, and B would be pi 3rds. So I would have the sine of 3 pi 4ths times the cosine of pi 3rds minus the cosine of 3 pi 4ths times the sine of pi 3rds. Okay, that's the formula. It's the sine of A times the cosine of B minus cosine A sine B. And I've just filled in the numbers. So then I can go out and I can look at my unit circle. Be careful, watch your signs. Okay, the sine of 3 pi 4ths is square root 2 over 2. Be extra careful. Make sure you watch the SIGN, the signs on your numbers. Okay, otherwise you'll get the wrong answer. Okay, so the sine, SIN of 3 pi 4ths is square root 2 over 2. The cosine of pi 3rds is, is 1/2 minus the cosine of 3 pi 4ths is negative square root 2 over 2. And the sine of pi 3rds is square root 3 over 2. Okay, so then I'm going to multiply them together. Remember, do the numerators together and then the denominators together. So when I multiply them, I have square root 2 over 4 minus the negative square root of 6 over 4. And I can simplify that just a wee bit. Okay, I would have square root of 2 I'd have square root of 2 plus minus makes a plus square root 6 all over 4, and that's going to give me the sine of 5 pi 12ths, the exact value of the sine of 5 pi 12ths. Again, remember, guys, you do not have to memorize the formulas. The formulas will be on a formula sheet that you can use. You can have the formulas handy when you're taking your homework, when you're doing your homework, or when you're taking the online exam, and then also for the final exam.